Before explaining that PPTs, so you just overview on this fourth normal form. What is this fourth normal form? Why we need this fourth normal form? Okay, how to find out the table is having a fourth normal form or not? Whether the table is violating fourth normal form or not? Right? Right? So till first normal form to BCNF, you know how to find out the that table or that functional dependency is violating that related to particular normal form. In the same way, there is some condition to find out how the table or when the table is violating the fourth normal form. Okay. Uh, as we seen in previous classes like second normal form, third normal form, and BCNF, what is the basic criteria? It is common for all normal form. That is, it should satisfy its previous normal forms, right? So if I'm finding out a second normal form, whether the table is valid to second normal form or not, what is the basic criteria? The basic criteria is that the second normal form should satisfy, the table should satisfy the first normal form. Then only I can find out whether the table is having second normal form or not. When it comes to third normal form, the table should satisfy second normal form. When it comes to BCNF, the table should satisfy the third normal form. Then only we can able to find out whether this table is having a violating that particular normal form or not. In the same way, when it comes to fourth normal form, right? Which is the previous normal form before this fourth normal form? It is BCNF or 3NF. Right? Basic condition is what the table should satisfy. Means it should satisfy the 3NF or BCNF. Right. So this is the basic criteria to find out whether the table is having or violating a fourth normal form. Before finding out, we want to check. We have to check the table is violating third normal form or not. If it is violating, first we have to apply the third normal form procedures to resolve. Then we're going to see whether it is violating fourth normal form or not. This is the basic criteria in all the normal forms. Right? It should satisfy the previous normal forms. Right? It should satisfy the third normal form or BCNF in the fourth normal form. And next, very important condition, there should not be a multivalued dependency. Okay, there should not be a multi-valued dependency. Right? So in second normal form, we seen that the table should not contain a partial dependency. In third normal form, it should not have a transitive dependency. Right? When it comes to fourth normal form, it should not be a multi-value dependency. Means if the table is having a multi-value dependency, then we can say that the table is violating fourth normal form. Right? Before explaining this fourth normal form, we should understand, right, what is this multi-value dependency, right? So we have types of dependencies. One is trivial, non-trivial, multi-value dependency, and last one is the transitive dependency. We see the transitive dependency in the third normal form, and it is partial dependency in the second normal form. And when it comes to fourth normal form, we're going to see multi-value dependency. What it indicating? Till BCNF, we are using a single value dependency, nothing but the functional dependency. It is X determining Y. When it comes to fourth normal form, this we are going to check for complex databases. As I said, this is going to check for complex databases. So if we are trying to find out if whether the table is violating fourth normal form or not, what we're trying to check? We're trying to check whether the table is having a multi-value dependency or not. If the table is having multi-value dependency, then we can say that the table is violating fourth normal form. So first we're going to see what is multi-value dependency. We say it as MVD. Okay, multi-valued dependency. So multi-valued, by the name only we can say that if the attribute is having multiple values, this fourth normal form is somewhat related to first normal form, right? But not completely as the first normal form. Here the condition is different. Okay, here the total criteria is different, right? But some version we're going to take it from the first normal form, because in first normal form also we're going to see multi-valued attribute. Here we are going to check multi-valued dependency. So here we are checking for multi-valued dependency. So what is this multi-valued dependency? We X determines Y. This is a single value dependency, nothing but functional dependency. Here we're trying to find out, we're trying to see which one multi-value dependency means. We have if any of the attribute are determining any of the other attribute multiple times, then the dependency we say it as a multi-value dependency. Here, this is the notation. This is the syntax for finding out the multi-value dependency. X double arrow mark, then determining Y. This is the multi-valued dependency. So what is indicating that for single value of X, here single value, here X value will be single. For this single value, there may be a possibilities of having a multiple values. Okay, for X, single value means it is determining the multiple values. In functional dependencies, one value determining one attribute only. Okay, one attribute value. But here in multi dependency, if one attribute value are determining multiple values in the Y side, the Y component, then that table or that dependency is having a multi-value dependency. Means I will just write for X, right? X is single value, for single value of X, right, more than one value of Y is possible. Y is possible. Okay, I will give you an example here. See, what is this example? Example for this one: student. Okay, one student. That is student name you can take, or student ID you can take. Student ID. Okay, one student. This is the attribute. This is the attribute, right? Here I'm giving student ID name has 100. Okay, another Y component I will take, means another attribute I'm taking subject, right? This student, the student 100 can have multiple subject, means he can read C, right? He can read Java. You can take yours only, like 5th semester. One student are right taking how many courses? 6 courses, right? Like your DBMS and computer networks and labs, right? One student is having multiple values. Here X is what? Student ID, and Y is what? Subject. Means for one value, for single value of X, that is 100, can have more than one values. It can be having a more than one values. It may possible to have a more than one values, right? If we find this type of dependency in the table, then we can say it as it's a multi-value dependency, because one value can have multiple values, more than one values, right? So X is determining more than one value, sir. 100 determining C, 100 determining Java, it is 100 determining computer networks, and 100 determining Python. 5 subject. If one student is taking 5 subject, means one single value is determining 5 values there, right? If we found this type of dependency, this type of value on the table, then we can say that the table is violating what? Fourth normal form. Is violating fourth normal form. Just I have taken 2 examples, means 2 attribute value for the example, right? But to say the table is violating multi-value dependency, the table should contain minimum 3 attribute values. Means it contains at least 3 columns. Okay, it should contain at least 3 columns. Nothing but it should at least contain 3 attributes. Here student ID subject. I just taken 2 attributes for explanation, right? For understanding purpose, right? But to find out whether the table is violating multi-value dependency or violating fourth normal form, the table should contain at least 3 attributes: subject ID, student ID, subject, and you can take it as subject ID. Subject ID. Then we can find out, then we can see whether this table is having a multi-attributes, multi-dependency or not. Why we have to take the three attribute values, or three attribute means one more criteria, one more condition to be checked while we finding out whether it is a 4 comma form or not, right? So which is that those two attributes, whichever the attributes that X is determining, right, that those two attributes should not be dependent, it should be independent. Okay, it should be independent. Okay, what I am trying to say, three attributes should be there in the table and two attributes are independent, right? Then the attributes, that is what we can consider, this has X, this has Y, and this has Z. Subject ID has Z. Okay, here three attributes should be there in the table and Y and Z should be independent to each other. Should be independent to each other. Okay, here this example which I have taken, it is a dependent subject. With the help of subject, I can find out subject ID. With the help of subject ID, I can find out subject here. But I just given an example here, right? So one more example I will take. Okay, one more example that is relevant to this multiple dependency. That is employee. As we can take as a we are seeing that employee table, right? So employee table, I will take the employee name and the phone number of the employee and the project number. Then the project number. Consider this is the table. Now I want to find out whether this table is having a what multiple dependency or nothing, but we're trying to find out whether this table is violating 4 comma form or not. Right. First condition to check, it should be in 3NF or BCNF. Right. Yeah, if it is in 3NF BCNF, then we're going to check whether it is multiple dependency or not. Right. I'll just give the value over here. RAM, phone number 888, and the project number is 1. Okay, as I said, if the X value can have a more than one value, so I'm taking two values here. 999 means this RAM is having a multiple phone number and is working in the project, that is project 1 and 2. Now I will take one more, it is Sham or Sham, you can take Sham. So just take 111 for once and you're working in the project number 3. Now this is the table we have. Now I want to check whether this table is violating this multiple dependency. How to check one? Right. First condition is what? 3NF, it is there. Next, whether this table is having 3 attributes. Yeah, it's having 3 attributes: employee name, phone number, and P number. This condition satisfies. Next, Z should be Y and Z should be independent to each other. Means here, with the help of phone number, I cannot find the project number on which project this RAM is working. Right? This phone number and project number both are independent. Right? This phone number and the project number both are independent. Right? Here X is the employee name. You can take X as employee name, and the project name has phone number has Y, and the project name has Z. Okay, I've taken the same attribute name here, so I will take PH4, that is phone number. Okay, this is the table. Now, how to find out this table is having multiple dependency or not? Correct. So we just compose this table. Means just find out the combination of the values, whatever we have, whichever we getting for this values. From here, RAM is the X value. What is the possible values for RAM? 888. This is 888. It is 9, 8 and 9, and the project number is 1 and 2. Right. So take the value. Just try to find out the value over here. Take the same thing. Employee name. Employee name is what? RAM. Right. And the phone number is what? 888. I will write. And project number is what? This is a one possible values. Right. RAM 8 and 1. This is the one possible tuple I can get from this table. Second value is what? With the same thing, RAM 999, project number is 2. Okay. Again the same thing I can get. Another possible value is what? Now I got RAM 888 This is one combination value. RAM 999 This is another combination value. I can get RAM 888 because this project number is related to now. This is the same employee RAM, right? So another possible value I can get RAM 888. Project is what? 2. Same thing. RAM 999 project is 1. For RAM, right? For RAM, I can get 4 possible tuples. 4 possible tuples on a single table. Right? So what is that? Employee name, this RAM can have a number, it is phone number and project number. Right here, project number and phone number are independent. But phone number and employee name are dependent. Nothing but X determining Z, then employee name determining phone number. These two attributes, these multiple attributes are depending on the E name. Right? So, but phone number and project number are independent. With the phone number, I cannot find out the project number, or with the phone number, I cannot find the project number, or with the project number, I cannot find the phone number. With the help of project number, I can find the employee name, or with the help of employee name, I can find the project number. Right? This is, and one more value I have sharp. That is doesn't have any multiple values, so only one attribute. Stamp 111 and you are in the project number 3. Right. So here this condition is satisfied 3 attributes. Yeah, I have 3 attributes and Y and Z are independent to each other. Right, independent to each other. We can consider this as the T1. I have a formula, right, to find out T1, it is T2, you can take it is T3, T2, T3, T4, this is T5. Okay, these are tuple 1, tuple 2, tuple 3, tuple 4, tuple 5 values. Right. So while finding out the functional dependency, we have formula, right? T1 of X should be equal to T2 of X. If those two are equal, then we are trying to find out T1 of Y equal to T2 of Y. If all those values are equal, then we can say that is a functional dependency. In the same way, we have a formula for multivalued dependency, right? We have a formula for multivalued dependency in order to find out, which is that here we having how many attributes? 3 attributes. Means you will get 3 formula to find out. There we have 2 attributes, minimum 2 attributes. We can manage the X and Y, right? So you can find out the 2 attributes. Here we're going to find the 3 attributes, nothing but T1 of X, sorry, not T1, T3. T3 of X equal to T2 of T4 of X and T1 of X equal to T2 of X. This is the one condition, right? So if this condition satisfies, we're going to check the Y value. What is T1 of X here? Sorry, T3 of X. It is the X value here, which is one. It is X value. Employee name. X is the employee name here. Y is the phone number, and the project number is Z, right? T3 of X is what? RAM. T4 of X, same RAM. Then T1 of X, that is RAM, and T2 of X, RAM. Yeah, this condition is satisfied. Then we are going to check for second condition. It's the second condition. that is y condition. The same thing, T3 of y equals to T4 of T1 of y, and T4 of y equals to T2 of y. What is the value for T3 of y? Is 888. This is the phone number, right? Then T1 of y 888. Then T4 is 999, and T2 999. This condition is also satisfying. Now the third one, if two conditions satisfied, then you have to check with the third z also. So T3 of z equals to T2 of z and T4 of z equals to T1 of z. Now we have to check the value. T3 of z, that is 2, project number is what, 2. Then T2 of z, project number is 2. And T4 of z, project number is 1. And T1 of z, project number is 3. Okay, here we are going to find out two possible relations. It is employee name and the phone number. Another relation is employee name and the project number. And we have find out what we have tried these rules on the table, and it is satisfying, indicating that this table is violating what? Multivalued dependency. It is violating multivalued dependency. Right? How to recover this multivalued dependency? The same thing, decompose. Right? Going to split the table. We're going to take two relations. Means we want to create the two table by the name, employee name and the phone number, one table, and the employee name and the project number, another table. So employee name Ram 888, 999, Sham 111, and for another table employee name project number Ram 12 and Sham 3. We're going to create a separate table. Okay, we have to create the separate table. Then by creating separate table, this will get the fourth term of form violation will be resolved on the table. Okay, so just give overview on this one. What this fourth term of form said, it should satisfy the third term of form of BCNF, and we have to check whether this table is having multiple dependency or not. If this table is having multiple dependency, then how to find out that table is having multiple dependency on the table? We have this formula. Right. If this is having a multi-dependency, means we can say that the table is having a what? Violating fourth normal form. Right. Before that, it should have a 3 attribute. At least 3 attributes should be there, and y and z. These two are what? Independent to each other. It should not be a dependent. It should be independent to each other. Okay. And this x value can have a multiple values, which you can have a number of more than one values, that is possible values for this x by using y and z attribute. Okay, this is regarding a fourth normal form. Right, this is a simple example. Now, when it comes to PPT here, what does multi-dependency says? Multi-dependency comes under for fourth normal form, and multi-dependency are the consequences of the first normal form, because a multi-dependency means multi-value attributes. There we're going to take, right? So the same some part we're going to use in the fourth normal form, right? If have two or more multi-attributes, independent attributes, the same relation schema. Here we have how many attributes? 2 independent attributes. It should have a minimum of 2 independent attributes, and we get into problem of finding a repeated values on each attribute. So if we have two multiple, means we have 2 independent attributes here. So we got a repeated values. Okay, RAM is having the 4 tuple having for RAM only, right? So there we can find a multi-value dependency, right? So x double arrow y, this is the notation for finding what the multi dependency on the given relation are. right? If T1 and T2 exist in relation, then T1 of x equal to T2 of x, then two tuples T3 and T4 should also exist. If this exists, then we can say that it is having a what? It is violating a fourth homomorphism. That is T3 of x equal to T4 of x and T1 of x equal to T2 of x. These three conditions, these three formulas we're going to find out on the given table, right? This is the table for fourth homomorphism. This is the table they are given: name, e-name, project name, and the dependent name. Okay, this is the table they are given. Smith, all employee name is Smith, then project name is XY, then the dependent name is John, Anna, and John, right? So if you if you take this value Smith, X, and all, right? You having multiple values for the same project name for Smith, right? Then only for dependent name is differ. Here project name and dependent name are independent. With the help of dependent name, I cannot find out the project name, or with the help of project name, I cannot find out the dependent name of this employee. But with the help of this employee, I can find out project name. With the help of e-name, I can find the dependent name. But these two are not dependent, these two are independent, correct? Then we're going to decompose this table into two tables. It is Smith is having how many project? Project he is working on two projects, Smith X and Smith Y. Then next is employee name, dependent name, John and Anna, Smith for John and Smith for Anna. Here, by decomposing, by splitting this table, we can avoid the fourth homomorphism, that is violating the fourth homomorphism. This is one example. Example 2, we just added some more values to this same table, right? Smith, e-name, Brown, right? We added two values here, Smith and Brown, and the multiple project name here, X, Y, Z, W, and all we're going to add it here, right? And some we added the dependent name. We split this value, split this table, depending upon the project name, this employee name and the project name, so this becomes the one relation, and employee name and dependent name becomes the second relation, right? E name and project number, Smith, X and Y, then Brown, W, Brown, X, Y, Z. We are just giving a only single value we are taking after splitting, and here Smith, Anna, Smith, John, Jim, John, and Bob. Right, this is example 2. While after splitting, if the table is having fourth homomorphism, it will be resolved. It will be resolved.